A conformational isomerism. The symmetry of sigma bond around the internuclear axis of alkanes permits the free rotation of two carbon atoms with respect to each other. For example, if we will take an example of an alkane, that is suppose ethane, so there is a, due to this carbon-carbon single bond, there is a free rotation occurs. Okay. Now the rotation about the single bond results to different spatial arrangement of atoms in space, which can change into one another. Due to this rotation, there are different arrangements are possible in space. Now these interconvertible forms arising from rotation about carbon-carbon single bond are called conformational isomers or conformers or rotational isomers, and the phenomenon is known as conformational isomerism. Due to this rotation, the arrangements which are possible are known as your conformers, okay, or rotational isomers, and the phenomenon is known as your conformational isomerism. Now the rotation around a carbon-carbon single bond is not completely free. This rotation is not completely free because of the weak repulsive interaction between electron clouds. There are different bonds are there in which there are in between the different electron clouds there is a force of repulsion arises, which is known as the strain, which is known as your torsional strain. Okay, so due to this type of repulsive force of attraction, different conformers are possible, and here there are two extreme conformers are possible, which are staggered. One is known as staggered form, another is known as eclipsed form. Okay, we'll discuss that in later. Now the conform lying between these two extremes, in between these two extremes, also there is another conformer is present, that is known as skew conformer or Gauge conformer. So this eclipsed form and staggered form can be represented in two forms. One is Sauer's projection, another is Newman projection. Okay. Now see here, this is ethane, where this dot represents one carbon atom, this dot also represents another carbon atom. Okay. Now this form is known as eclipsed form. This is CH3, single bond CH3. This is known as eclipsed form, and this type of form is known as staggered form, where you observe that here the arrangement of hydrogen atoms in between in the two extreme carbon atoms are different, and here also the arrangement is different. So this type of arrangement, that means these two forms are different in their arrangement of atoms. Okay. Now in Newman projection, what happens? One CH3 carbon, this point represents one carbon atom, and this circle represents another carbon atom. The point represents the near carbon atom, which is near to our eye, and the circle represents the carbon atom which is away from our eye. Okay. Now this is another one CH3 molecule, this is another CH3 molecule. Similarly, in staggered form, what happens? Here also the point represents one carbon atom with CH3, and the circle represents the rear carbon atom, which is away from our eye, along with the three hydrogen atoms. Okay. Now the comparison of stability between eclipsed form and staggered form. In eclipsed form, what happens? Hydrogen atoms of one carbon atom are directly behind the other. Okay. Due to this, there is a repulsion is maximum in these atoms because they are near to each other, so there is a repulsion is maximum, and due as repulsion is maximum, so energy is also maximum, and energy is maximum, so it is a least stable form. Okay, higher is energy, least is the stability. But in staggered form, what happens? The hydrogen atoms of the two carbon atoms are far apart from each other, due to which the repulsion is minimum. Okay, when the repulsion is minimum between two atoms, that means energy is minimum, and this is the most stable form.